So now that you know how to calculate the molar masses of elements and molecules, it's now time to learn how to use molar masses to calculate the number of atoms in a substance. So to recap, we have now learned what a mole is. A mole of any element is 6.02 times 10 to the power of 23 atoms of that element. So how much does that mole weigh? That's what the term molar mass is all about. 1 mole of any element weighs in grams what it says on the periodic table. So the word weigh is not actually appropriate because based on where you are in the universe, things will weigh different amounts. So we use the word mass. The mass of an element is the more proper term. So you can find the molar mass of an element by looking on the periodic table, and likewise you can figure out the molar mass of a molecule by adding up all the molar masses of the atoms inside that molecule. So for example, what we just showed you earlier, H2O has a molar mass of 18.02 grams per mole. You won't find H2O on the periodic table. You'll have to look up the molar masses of each of the atoms inside that molecule on the periodic table. So if you have an ionic compound, such as NaCl, we can't use the word molecule. We have to use the word formula unit. This is because technically NaCl is a positive ion and a negative ion joined together with an ionic bond. Technically, there's a whole bunch of these formula units all stuck together in a crystal lattice structure that looks something like this. Here you see the chloride ion and the sodium ion, and these two would be a formula unit. And there's all these other formula units that are joined together, and they make this crystal lattice structure, which looks like a cube in this picture. So let's see how we can convert the mass of a substance into the number of particles of a substance. In other words, let's start doing some calculations. So we use the word particles because depending on what substance we have, we're either going to call them atoms. So that's if we're working with elements, we call the particles atoms. If we're working with molecular compounds, we're going to use the word molecules. And if we have ionic compounds, we use the word formula units. Let's use the example of carbon. If we have 24.02 grams of carbon, how many atoms are there? First, we're going to calculate the number of moles. Next, we're going to calculate the number of atoms. And remember that each mole has 6.02 times 10 to the power 23 atoms. So how many moles are present if you have 24.02 grams of carbon? Well, what are we given? We know the molar mass of carbon by looking on the periodic table is 12.01 grams per mole. We're looking for the number of moles, so we use this formula, mass over molar mass. And here we go, 24.02 grams of carbon divided by 12.01 grams per mole is equal to 2 moles. Now we can go into the second step. How many atoms are there? So if we look at this formula, we see the number of atoms is found by multiplying the number of moles by Avogadro's number, 6.02 times 10 to the power 23, and there's units here, atoms per mole. How many atoms are present in 2 moles of carbon? First, you're given 2 moles of carbon, and you're trying to find the number of atoms. So we use this system of given, required, and solving to help us organize our thoughts before we solve the problem. It may seem like a lot of work at this moment. However, as the questions get more complex, it really pays off to follow this method. So the number of atoms, again, is equal to n times Avogadro's number. This symbol, n subscript a, is Avogadro's number. N times 6.02 times 10 to the power 23 atoms per mole. You put the 2 moles where the n is and multiply it by Avogadro's number, and you get 1.204 times 10 to the power 24 atoms of carbon. Well, I hope that helped you. I know this is a very difficult topic, so you may want to watch this video again. If you have any questions, just ask your teacher. Thanks for listening.